Welcome everyone to this week's Science News. Today we'll talk about superchemistry, music in the brain, how to create matter from light, contrails, objects that take strange turns, why phone batteries might soon become replaceable, how to control fire, why we have to think about preventing hurricanes, and of course, the telephone will ring. Before we get to the news, a brief channel update. I'll be away for the next 2 weeks, so there'll be no science news on August 30th and September 6th. The Saturday videos are pre-scheduled and will appear as usual. Our newsletter will also go out as usual. You can subscribe to that at sabinehossenfelder.com/newsletter. It's completely free and goes out once per week. We'll be back to normal in the second week of September. Researchers at the University of Chicago have found evidence for superchemistry. That's chemical reactions that are enhanced by quantum effects. I'd honestly never heard of this, but come to think of it, it makes perfect sense. You see, chemical reactions can happen both forward and backward, if enough energy is available. You can describe this process by a quantum mechanical oscillation between two energy states. Normally, this description isn't any good, because at room temperature, quantum effects are completely washed out by thermal motion. But if you cool the atoms or molecules down, you get quantum coherent states, and you should be able to see the oscillation. This phenomenon was theoretically predicted more than 20 years ago, but this is the first experimental realization. For their experiment, they cooled cesium atoms until they formed a coherent condensate, and then watched the simplest reaction you can think of, which is when two atoms come together to form a molecule. You can see in this figure that the number of single cesium atoms and molecules of two cesium atoms indeed oscillates back and forth, like you'd expect for a quantum system. It kind of tapers out a bit because decoherence comes back to bite you. They also found that the more particles involved, the faster the reactions occurred. The researchers now want to try it with larger molecules and more complex reactions. So we have superpositions, superfluids, superconductors, supersymmetry, superdeterminism, and now superchemistry. Let's just hope in the end it won't all turn out to be superfluous. A group of American scientists has reconstructed a song that people were hearing from measurements of their brain activity. The song in question was Pink Floyd's Brick in the Wall. Here is part of the original that the study participants got to hear.
All it was just a brick in the wall.
And here is the reconstructed version. The researchers recorded the brain activity from electrodes implanted in the brains of 39 individuals with epilepsy. These electrodes are there for medical reasons, so it's not like the researchers could pick their positions. Consequently, for some patients the reconstruction worked better, for others not so well. But generally, they could clearly identify a response in the auditory areas of the brain, not only with the frequency variation, but also with rhythm, harmony, and even the lyrics. Interestingly enough, they also found that while using signals from more electrodes improved the sound reconstruction, as you'd expect, the improvement only increased logarithmically. That is, you really only need 24 or so electrodes to get a fairly good reconstruction, and then adding more only leads to slow gains. This is both bad and good news. It's good news in that it means you don't need all that many electrodes to get a decent signal. It's bad news in that if you want to go from decent to great, you'd need many more electrodes. Reconstructing songs from brain activity is impressive for sure, but I wish they'd find a way to get some songs out of my brain. Hello. Hi, Elon. It's too bad, really. I like the idea of you in a cage fight with Mark Zuckerberg. It'd have been so exciting to see who'd win. The rich guy who failed at rebranding their social media platform, or the rich guy who failed at rebranding their social media platform. I love you too. Bye. The cutest physics paper of the week, according to my totally objective opinion, comes from a group of physicists in Japan and the United States who found a new way to create matter from light. Yes, it's possible to create matter from light. It's just a conversion of one type of energy into another. For example, in the early universe, antimatter annihilated with as much matter as there was around, creating a lot of light. We're basically what's left. But the same process can also happen in return, at least theoretically. Matter can be created from light. In practice, the difficulty is that creating matter takes a lot of energy, so you need light with a lot of energy to make it. Or rather, the quanta of light, the photons, need to have a lot of energy. As you may know, light doesn't directly interact with itself, so you need a virtual exchange particle to facilitate the interaction between the photons. That could be any charged particle, but the easiest one to produce is the one with the lowest mass, and that's the electron. It's called the Bright-Wheeler effect. From two photons, it produces an electron, and its antiparticle, that's the positron. The researchers now suggest doing this not directly by shooting lasers at each other, but by shooting lasers into plasma, where the laser creates a shock wave. The shock wave then displaces electrons, which creates a strong electric field in the plasma, which creates more photons. So it's really complicated. But the researchers say that with a suitable plasma and a suitable laser, they can achieve what they call a self-focusing of the laser pulse. Now, this was just a computer simulation, but they say that with a currently existing high-power laser, this would create as much as 10 million positrons per pulse. This is interesting not just because creating matter from light is as close to magic as science gets, but also because positron beams are very useful in material science. I really hope if they do the experiment, they push the button with the words, "Let there be matter." Google's AI team has worked with American Airlines to reduce contrails, and their efforts are now seeing the first results. Contrails, short for condensation trails, are those wispy lines that airplanes leave behind. They may look pretty, but the problem with contrails is the same as with other thin clouds, the cirrus clouds high in the atmosphere. It's that they trap heat and thereby contribute to global warming. The role of contrails in climate change is surprisingly large. The IPCC estimates it's about 35% of the warming attributed to aviation, which is itself about 2% of the total. But not all flights create contrails. They're only created when the humidity at those high altitudes is high enough. The engine emissions then create condensation seeds for ice crystals, which form those clouds. So if one knew where contrails are likely to be created, one could route airplanes around those areas. Google Research has been working on this for more than 10 years, developing artificially intelligent software trained on satellite weather data. They now did an experiment that saw pilots from American Airlines conducting approximately 70 test flights over 6 months. The results were encouraging. Following the AI-driven recipe, the flights reduced contrails by 54%. But the reason airplanes fly those routes at those particular altitudes is that it's the most energy-efficient way to get from A to B. Deviating from those routes to reduce contrails increases fuel consumption. According to the Google researchers, the increase is about 2%. On the other hand, the carbon footprint of fuel emissions can be reduced by other means. For example, switching to synthetic kerosene that's been synthesized by renewable energy. It won't be long now, and you'll need carbon offsets for your marriage proposal. A group of scientists from South Korea and Switzerland just published a paper in Nature in which they show how to make an object roll along any path. Objects roll on inclined planes on a path that depends on their shape. This group of researchers asked, can we turn this around? Instead of calculating the path from the shape, can we calculate the shape from the path? They found a way to do that and then 3D printed the objects to measure how well it works. As you can see, the objects take some, strange turns. Now, the paths that they look at are not completely generic. They looked at cases that can be complicated, but eventually have to repeat. This is because the longer the path is before it repeats, the more structures you'd need to put into the surface of the object, and eventually the features would just become too small. Also, the path needs to respect the laws of physics. There's no shape that'll make an object roll uphill, or generally too much to the side. These shapes you see here are made of plastic, but in the middle there's a heavy metal ball, so the center of mass is easier to calculate. As you can see, their method works amazingly well. This is one of the cutest examples of applied mathematics I've ever seen. Though seeing that it took almost 1.5 years between submission and publication of the paper, I guess getting it through peer review was a little painful. Who needs self-driving cars? Or just bundle up in a plastic cocoon and roll to work? The European Council has passed a law that requires smartphone batteries to be replaceable by 2027, like in this phone from LG. This law has been in the making since 2020 and it's undergone multiple rounds of revisions, but its final version was approved by the European Parliament in June, and a few weeks ago it also passed the European Council. Loosely speaking, the European Parliament is a little bit like the US House of Representatives, while the Council is more like the Senate. Now that both have passed the law, it's ready to go into effect. The new regulation affects all devices with rechargeable batteries, not just smartphones, but also tablets, cameras, laptops, and so on. The law explicitly states that batteries must be readily removable and replaceable by the end user at any time during the lifetime of the product. This law will probably not just affect the European Union. The EU market is so big that producers won't just abandon it, but they're also unlikely to put out two different products, one for the EU and one for the rest of the world, so it's likely to have a global impact. Though I think they only want to be able to remove a battery so that they can claim that the EU put power into the hands of the people. A group of researchers in America has found a new way to control fire and used it to create carbon nanotubes just by burning stuff. Fire is, loosely speaking, a chemical reaction that rapidly releases heat. In most cases, it happens by a reaction with oxygen. This is why you can put out most fires by covering them. Fire is extremely handy for treating materials. Just think about soldering or glass blowing. These researchers have developed a coating that can be applied to materials you want to treat with fire. The coating precisely regulates the oxygen supply to the material and thereby the heat that's delivered to it. They have used this in particular to create carbon nanotubes simply by burning cellulose fibers, just as they previously coated the fibers. The coating had the effect of concentrating the heat in the middle so that the fiber burned from the inside out, leaving a ring of carbon ash. They confirmed with a scanning microscope that the fibers were actually hollow. If this method can be scaled up, it could make the production of carbon nanotubes much easier and thereby cheaper. This would be very interesting because, as we just talked about in a recent video, carbon nanotubes are one way to build smaller transistors. Well, we discovered fire hundreds of thousands of years ago. I guess it was about time for an upgrade. I also wouldn't mind some of that coating next time I try to grill a mushroom. A group of scientists from Australia and the UK has looked into ways to manipulate tropical cyclones and prevent them from turning into typhoons or hurricanes. They say we need to think about the consequences before someone sets out to actually do it. Hurricanes have surged in destructiveness, inflicting a 7-fold increase in damage since the 1980s. Although improved early warning systems have saved lives, the economic toll remains substantial. A typhoon, by the way, is the same thing as a hurricane, just that the one is in the northern hemisphere, the other one in the southern hemisphere. They both grow out of what's called a tropical cyclone. I made an entire video about the question whether we can stop hurricanes a few years ago, and in case you've seen it, you may remember that the biggest problem is that hurricanes are enormous. A hurricane is typically the size of Texas or so. You're not going to stop something like that. Even nuking one wouldn't get the job done, and yes, Americans have seriously considered that. The best option we have is to stop them from getting large in the first place. The hurricanes, I mean. In my video, I arrived at the conclusion that preventing hurricanes will become possible sooner or later because it's ultimately a question of how soon you can spot one that's under development. The younger it is, the smaller the area that you need to target. Hurricanes form over the water near the equator when the water is warm enough. That's why there's a hurricane season. The warm water evaporates and rises. As it rises, it cools and creates clouds. This tower of water-heavy clouds begins to spin because of the Coriolis force. That draws in more air, which extracts more heat from the ocean, which drives the cycle. There are several ways you can stop a hurricane from forming, and they all work by disrupting the positive feedback that grows them. One way to disrupt the cycle is to inject substances into the clouds to make them rain off. Another one is to cover the surface of the water to prevent it from evaporating. Yet another one is to create disturbances in the rotating cloud system so that it breaks apart. It's also possible, at least in principle, to redirect a hurricane so it makes landfall elsewhere. In the review, they collect all these ideas. At the moment, they're all unfeasible, but it seems likely that sooner or later someone will try them anyway, so we need to think about the consequences for ecosystems, marine life, and political relations. So maybe the weather forecast will soon begin with today's storm brought to you by fundamental ideological differences. Thanks for listening. We'll be back in the second week of September.